Hello, today I will show you how you can draw the shear force and bending moment diagram of a fixed beam in STAAD Pro Connect Edition. This is the interface of the STAAD Pro Connect Edition. When we open it, you can see that we can give it a name and the location where we want to shape, and the type is there, analytical, physical, and building, and unit we can select. And I have already given its name, fixed beam, and selected its units. Now I have to just click on create button, just click on the create button, and now you can click on this grid or beam grid. Then you can see the grid, and now we have to keep this snap node oblique beam option to, so that if we want to draw the beam, we can draw it. So we have to draw the shear force and bending moment diagram of a fixed beam of length 10 meter with having UDL all over the beam. So just click on starting point. This is my end point 0, and our beam has been drawn. Uh, just click on ESC, press ESC, so that we have to get removed from that command. So if we click on the geometry, our beam is ready, whose length is 10 meter. You can see this is our beam number 1, and if we keep pressing on this beam, then we can see that there is a green line, there is blue line, and there is a red line in the middle of it. So this green denotes the starting of the beam, and the blue denotes the ending of the beam, and the red denotes the middle red portion of the beam. And now let's move to the step 2, which is the property in which we give the cross section to the beam. So I want to give a rectangular cross section to the beam having width 0.5 meter and depth 0.5 meter. So just click on this define tab, and we have various options in which shape which we want to go. And as I already said, I want to give a rectangular cross section to the beam. Just click on 0.5 meter, and here 0.5 meter. Okay, and our material is complete, already chosen it. So just click on add and close. So we want to assign this cross section to our beam, so we have to just assign, click already selected, assign to selected beam, and just click on assign, and just we have to click it on yes, so that it will be assigned. Now you can see that reference 1 is already assigned to this beam. Now we have to provide the support to the beam. For that, let's move to the next step, support. You can see that there is no support is here, so we have to create one fixed support. Just click on create and add fixed support, and we have to assign this fixed support to the first and second node, that is the starting and the end of the beam. So just we can use assign to view option, and STAAD Pro is very smart. It will automatically assign to all the nodes. So there are 2 nodes on the screen, so just click on this assign tab and click on yes, and you can see that the fixed support is assigned to this first and the last node of the beam. And now click on loading tab, and we have to make one load cases detail. So click on load cases detail, add, and we have, as we know that there is some dead load of the beam, which is the self weight of the beam. So we have to click on loading type dead load, and we have to give one title of that load. We can choose any title as per our choice. I want to give DL as the title. Just click on add and close this tab. And we have to also add live load, because as UDL is entirely on the beam, so UDL act as a live load over the beam. So we have to choose live load and make again a title, give a title LL, and just click on add and then close this tab. And in DL we have to add the self weight of the beam. So in DL, click on add, and we have to assign the self load. So its factor is already chosen -1, and direction is y direction, that is the downward direction, because self weight always acts in the vertically downward direction. And then click on add and close this tab. And in LL we have to add the UDL. So we have to go to the member load, and in member load we have to select the uniform force we have, because we want to apply the UDL. And you can see there is one prototype given to understand the situation according to which we have to apply the load. So you can see that what is D1, what is D2, and D3, what is D3. So as my load is of 10 meter because the UDL is entirely on the beam. So we have to give D1 as 0 and D2 as 10, so that it will automatically apply to the entire length of the beam, and click on add and then close. And in self weight we have to assign entirely on the beam. Just click on self weight and assign to view, so it will automatically assign to the entire length of the beam. Click on OK. And in LL we have I forget to add the amount of the load. So you can give the amount of the load as 10 kilonewton per meter, because it minus, because it is acting in the vertically downward direction. So okay, so we have to assign this on the entire length of the beam. So assign to view, assign, click on yes. And you can there is some problem in the graphics of the Connect Edition. If it is not showing the load, if we change something here, like if we edit it, add the load, it will show you the load. So if we change it 5 and change, now it is showing. So there is problem in Connect Edition with the graphics of the Connect Edition, because I have the crack file installed in my laptop. So it's there is a problem in it. So go to analysis tab and define commands, and we have to perform the analysis and no print. Add the command and just close. And now click on run analysis tab, run analysis, save, and you can see there is 0 error and 1 warning. We can ignore that warning. Let's see the warning. What is the warning? You can see that this is the warning, all degrees of freedom fixed, and this we can ignore because we already know that in fixed beam all the degrees of freedoms are closed. So this warning is not important for us, so we can ignore this warning. And now we have to go to the post processing mode and apply and click on OK. You can then we can see the movements and actually there's a you you can see that so you can see the reaction of our beam. This is the beam result of the beam, our shear force, bending moment, etc. So in this way we have obtained the reaction, shear force, bending moment of our beam, which is fixed at both end and having a UDL over it on the entire span of the beam. Okay, thank you so much.